Hey everybody, this is Larry. This is day 13th of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think. So I actually spent a long time on this one, even though it's an implementation heavy problem. Flatten nested list iterator. I usually solve this live, so feel free to fast forward, and you can kind of watch me solve this live as you do normally on my videos. But because this video is a little bit long, I want to just skip to the solution a little bit. So this is a nested iterator, flatten this nested list iterator. So the way that I did it was basically treat every item as like a tree and just doing a depth first search. And I would say usually, to be honest, I don't implement stuff that is very Python specific, even though sometimes I use Python notations, but very generally it is readable in any other languages. But in this case, I spent a lot of time understanding nested integers, and you can watch me, try to solve it and explain it while I'm doing it. But this is my code. Basically, I just do a depth first search of each thing, and then do a recursive yield, which in Python works. The only other thing is that Python doesn't have has next for iterators, so we have to kind of cache looking forward, like a peek, if you will, of these things. Otherwise, this is pretty much it. And we need two recursive functions because for some reason the input is a nested list instead of just a nested integer. So then you have this like thing here, which one to kick off the nested list, and then the second one that doesn't assume whether it is a list or an integer. Yeah, and this is just basically recursion, right? If this is an integer, then we just return the integer. Otherwise, we get for each item on the list, we go through them and then we return them. If you're in another language, I might recommend just flattening into one list and then just do a normal iterator, like going through the index. That's fine, much straightforward, though the space at one time complexity may be a little bit higher. With this one, it's probably more O of H, depending on how you want to do it, but it's still going to be linear in the worst case. This is going to be linear time and linear space because for each item, we only look at it a constant number of time and use constant number of space. That's all I have. I'm going to keep this short, keep this brief. You can watch the longer version of this where I go through this and maybe on 2x or, to skip forward a lot. Let me know what you think. I'll see you later and hope you enjoy me struggling with this one. See ya. Hey everybody, this is Larry. This is day 13 of the April Leetcode Daily Challenge, 2 weeks in. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Flatten nested list iterator. So I usually solve these live, so it's a little bit slow. Go fast forward 2x, skip ahead, whatever you need to do. Cool. So today's problem is a nested iterator. So basically you have list of lists and you want to kind of find them in a iterator kind of way. That makes sense. This seems like a common thing. And a bunch of this will be on, well, this is just looking at this interface. Okay, I was going to say that well, because in Python, this can clearly be, there are ways to do it, but in this case, then we just have solve the nested list. Maybe is equal to nested list. Let's see. So basically, I'm just looking at this interface right now just to see what kind of thing that we can do, and then. Get integer, are these all nested? Okay, so I guess this one by itself is also a nested integer of a nested integer. Okay. I mean, I'm just trying to think about what is this going, but because basically the general idea what I would like to do is just have an idea of a pointer to where things are, and then you just go one at a time. And I think the way that I would do it is by going for keeping track of a stack. I think the way that I don't know if that's the best way, but you can kind of have an index that keep track of, like a stack of index that goes as far as you want or as you need. Because it can be, for example, you can have a nested list depth of like 500 or something like that, and you have to go all that time. So I think I'll just have I'll have to first save the list and then maybe index stack. Maybe that's a better index stack to go to list, right? And let's just say it starts at 0, right? This is going to be a little bit implementation. I have to kind of think about it. But yeah, for next, okay. So then if, what do we do for next? Okay, so I think the only thing that I was double checking is whether, like, do we return an error code or something like that if it doesn't have any? But assuming that, it doesn't, I mean, we can just write something like, if not has next, return -1. I mean, this is just a placeholder. I don't think from the reading that this can happen, but yeah. And then we can use the same abstraction here, which is what does it mean for this thing to have a has next, right? That means that, okay, if self.index stack of the last element, so this is the yeah, if this is greater than or equal to the length of nested list, we return false. So otherwise we return true. I think, yeah, because then we'll do the increment on after we get the number for next. So yeah, so and of course you can kind of reduce this to this now, right? So yeah, I don't think I ran over the idea that much before implementing, but the idea is that we just basically have a stack that points to, like, for example, the first number will be this isn't quite right actually. This is not right. But basically what you want is that the first number will first go to the first index, and so of the nested list, and then you kind of go recursively almost in that way. I mean, conceptually, this is reasonable. It's basically an OR implementation problem. That's the part that I'm trying to figure out how to do in a good way. So yeah, so okay, let's just maybe I have a current is equal to, so that because I'm thinking that it becomes a little bit tricky otherwise. So yeah. Or like as you pop, you might have to figure out how, where to move the thing to. So that could be a little bit messy. So yeah, we'll wait to has next. Let's think about my next. So okay. So if self dot, no, this isn't quite right. This is a pointer to a nested int. Maybe this index stack doesn't really make sense either then. Let's just have pointer stack. Maybe that's more explicit. And then we can now set this to be self.nested list of 0. Now is that way? Because then you have to have a way to get next, and there's no way to get next unless you have to index. I guess that is the thing. Huh, okay, this is a really annoying problem to go. But yeah, okay. So if self.current is integer, then we return, well, you know, because I want to do this for two things. One, because I want to also have an increment function, which, move next, I guess. Is it called increment? Yeah, maybe I'll just call increment. But, and then this will get the next. So yeah, let's just say answer is equal to none. If next n is equal to self.current. Otherwise, otherwise this is a list. If this is a list, what do we do, right? Well, if this is a list, then we push to the stack. So else, while self.current is list, is integer. So while this is not an integer, we want to go recursively, right? So then now we go self.current is equal to self.current.getList. And we also want to push onto the stack another 0 for being like the first index that's in this new thing. And then at the very end, end is equal to self.current.getInteger. I forgot about that here. Okay. And of course we return answer, but we want to increment first. So what do we do on increment, right? So now we have this pointer. So we want to do self.pointer stack -1. We want increment by 1, right? And then is this right? I mean, the idea is right, but how do we get the correct pointer, right? Because this self.current only has a nested integer. It doesn't have. There's no way for us to go back, right? And the way to go back is to maybe I'll do this a little bit differently. This is a mess, I know. I apologize. This is kind of a tricky problem, at least for me. If you do it, but if you're able to do it quicker than I am, mad props to that. But yeah, how do I want to do it? I think we just have a pointer stack that contains all the lists, and then maybe that's a better way to do it. Because it should be pointers anyway, so it doesn't take that much more space. But it should be okay. So pointer stack is equal to self.nested list, say. Does that make sense? So then, okay, let's just say this is true. And then now if the top of the stack is integer, then we just set this to be true. Otherwise, while the top of the stack is a list, then we want the pointer stack to append dot pointer stack dot get list, maybe. And then and then this one will just keep on going up. No, is that true? Well, this is the last element, but it could be a list. And if you and this will keep on. This is an infinite loop. What I need to do is then, oh, okay. So the invariants are tricky. So this is a stack containing the list, and then we look at the first element, right? Let's just say we have an offset. Yeah, let's just do a list and an offset. And then we look at the last element, and if this let's just say top is equal to self.pointer stack and -1. If the top of 0 of top of 1, like possible list. Let's just say nested image. And sorry, friends, this is really terrible. But yeah, if nested integer is integer, then what happens, right? Then we have answer is equal to nested integer dot get integer. Otherwise what happens? That means that nested integer is a list. And then what we want to do is this is equal to this, and then we want to put this on the pointer stack with 0 as the index. Right, and then we keep going until it is not. So while, and I guess there's a walrus operator that we can do here, but we know that this is a list. So yeah, so, okay. Also, this is just one. Oh, and in this case, we will just we have to update it to increment. This is a mess. This is one of those implementation problems that I'm having issues with. I mean, you could do it more naively, to be honest, but I wanted to do it a little bit cleaner with a stack, but it's a little bit confusing. So if this is not an integer, we're going to implement a list here. And then at the very end, we just look at the last one of 0 of is this get integer, and then we do the same thing of incrementing, which is that we do self dot so top is equal to self dot pointer stack. I guess we can actually reduce this a little bit, so we will in a second. Yeah, self dot pointer stack dot pop, because what we want to do is we want to set self dot is equal to, we want the same list, but index over by 1. And here that we can actually change this to ends is equal to top of 0 dot get integer, assuming that we have this. Now we have this invariant. The invariant here is the invariant we want at this point is that the top of the pointer stack will contain an integer. This is a little bit. But this is a little bit bad, or a lot bad. Hang on. So then now we have to adjust. If the top of the stack is a list, we want to iterate until it is an integer. Okay. So while top is equal to the lowest operator, I don't know if this is quite the right notation. So while this of 0 is this integer, we push this is also wrong, by the way, but we'll fix it in a second. We want to push top of, so yeah, so the top will be, well, I guess there are only two things, right? A nested integer and an index. No, I guess this has to be right. So yeah, so now this means that this is a list. So we want to do top 0 that get list and 0. Okay. Else, at the very end, we append the value, right? So now we know that the last one is going to be an integer, so we get this integer. And then that's it. We'll just do -1, because this is an integer, right? So we don't have a list, so we have an index of -1 set. And then now we just look at this, the top will be an integer, so this is obviously going to be wrong. What we want is actually, so the answer is going to be top dot pointer dot that get integer. We have to do a lot more checks as well. Wow, I'm really struggling with an implementation problem. This is usually not the case, but maybe I'm just having, I need more sleep a little bit today. But now that this is an integer, so then we can pop off the back, and yeah. And this is a list. This is not, should this be 0? No, this should be top. If this is a list, then we want to increment for next time. Okay, maybe something like this. This is going to give us top sub 0 doesn't make sense. No, top sub 0 is the, okay, gives us the list. But we have to get the index out of the list as well, so I'm missing something. Oh, it's here, I think. This is the thing. This, no. So we know that this is an integer in the beginning. But we have to do the increment. I'm not doing the increment quite correctly. Well, I'm really struggling with this one. This is a new list that we do 0. Can you see the new list? This also keeps on getting the same list, so this is not right. This is get list of 0 and then 0. We want the first element of that list. And then here we want to pop, okay. Let's just try this again. Now we have to top the stack. What number do we get? Well, I don't know. I don't know. Maybe I'm trying to be really fancy, but not. So I'm going to just do it a dumb way, and then maybe we'll look it up. Sometimes I do struggle. I think this was actually pretty easy with depth first search, but I wanted to do it in a clean, iterable kind of way. But maybe it's just not the way to be. And we can actually do something like, you know, get list, and Python does have yield notation, but I don't remember how to do it. But it's just, yeah. And then my computer is a little bit crashing, of course it is. Sometimes during an interview or a contest, sometimes it helps to refresh yourself. You get, especially me, sometimes I get too stuck on a solution and try to sunk costs into it. But sometimes you just have to, just start afresh, start anew. But yeah, so then here we have if, how does this work? Nested list. So there's the first always a list? I guess so. For item in nested list, that's a little bit annoying though, because then I have to write two things. But for item in nested list, you item, you okay, wait, we do something like if item is integer, the yield item get integer. Otherwise we go for, I don't know why this is a nested list instead of just a nested integer, which would have been the same thing. Like, why is this not just a regular nested integer? That's very weird. But now I have to write two functions as a result. But yeah, okay. So for item for item 2 in nested list, in item dot get list, you get next nested of item 2, and that's going to be the same. Where get next nested is going to be nested. Just if nested integer is integer, we yield nested integer dot get integer for item in nested integer.getList, we yield get next nested item. Okay, then next we just go return get next of self.point. Oh, how does that go? Yeah, we just return self.pointer. Is that the notation? I actually don't remember the notation. Yeah, so whatever. Item is equal to maybe something like this. And then return item. Something like that, maybe? Hash next. Does Python have a hash next? Or did I just fake it? My computer is really slow. Sorry, friends. Don't know why it happens from time to time. It's Chrome being slow. Because it is, I don't know, running something in the background or something. I don't know. Like it's resolving holes, it's doing all sorts of funky stuff instead of what I needed to do. Okay, fine. Let's just return false for now, and then we can just see if this works a little bit. I'll just return true maybe. Okay, I mean, even once in a while, I don't know, my computer is just being sort of. Let me reconnect Wi-Fi. This is the kind of stuff you only get live. Maybe my DNS is just not up. Computer technical, whatever technical difficulties. My internet is down. All right, I'm gonna pause for a bit until my internet is back up, I guess, because what can I do when the internet is down? BRB. Hey, I'm back. Yeah, the internet was down for about like 10-15 minutes, so yeah, you get what you paid for, I guess. I don't know. But yeah, so apparently it doesn't, so I have to keep track of the next item. So yeah, let's do that. Next item is equal to let's self that formula. We have to do so we do a try, except what's it called? Stop iteration. And then we can just do return self that next item. It's not. And here we get item is equal to self that next item, and then self that next. We'll have to do this one, I guess. It's a little bit hacky, but I spent a lot of time on this already, so let's see if this will at least work. Let's keep code. Oh no. Oh, it's self.dynamics, but okay. Let's see. This is 2. Oops. That's a little bit sad. Is this not right? Let's print this out there. Try and do something new. We do have generated the objects. 2 and then more generated objects. So this gives me a generator. I was hoping that this would actually give me you. So basically, we want this to be, yeah. Get list. Is this right? Okay, so this is more right, but it's still wrong. Well, it's printing the right things, but it's not returning the right thing for some reason. This also looks sketchy as well, but yeah. Let's try this real quick. Yeah, I mean, it's printing the right stuff here, which is happening here. But for some reason, this is not. Because this is an iterator. So this should give me, right? Why is this not? Why are you wrong? Yep, this is a generator. So I think we're mostly right, but we're a little bit off in presentation, and that's just from me being weak at stuff. I mean, even this has to. Oh, am I just printing? Am I returning the wrong thing? Item is equal to sub item. That doesn't make sense, though, does it? Well, thanks for learning with me. A really long video. That doesn't print anything. Why is that? Doesn't even print out one thing. That's weird. Oh, it's because this returns has none 0 to force. I am just dumb then. Okay, there we go. That was a very actually silly mistake. We had it right mostly of the time then. I just had a, I raced through the has next. So yeah. Okay, let's give it a submit and hopefully that's good. Cool. And this is going to be linear time, linear space, because essentially this is just like a depth of search for a tree. And that's probably the way that I should have done it to begin with, even though I had to learn a few things for the get next and then to get next nested. But yeah, this is very Pythonic. So usually I try to write code that is not specific to Python, but in this case it is. But you can also just do a depth of search and then construct it, find it into one list and then do it that way. Even though, yeah. Yeah. Yeah, this notation is really wacky, but yeah, I'm actually new to these notations. So if you're good at Python and you see, let me know for any feedback. But yeah, but this is going to be linear time, linear space, because it just goes through each item on the list once, and for each item on the list, it uses all one space or all of all together. Yeah, this is a heavy implementation problem, or like you have to know what you're doing for implementation, or it's really implementation specific. The algorithm part isn't that interesting in the sense that it is just keeping track of a lot of us trying to keep track of stuff in a good way. And I try to spend a long time on an implicit stack, but or sorry, on an explicit stack, and at the end I just go back to an implicit stack because I was a little bit lazy, or like I couldn't get it to work really well. It was a little bit tricky. Let me know what you think. Hit the like button, hit the subscribe button, join my Discord, and hope you had a great day. And I will see you tomorrow. Bye bye. Good mental health.